Nicole Melendez. I am a structural engineer, and I'm very excited to be here today at the Next Frontier conference. Today, I wanted to talk to you guys a little bit about engineering, and I wanted to tell you about what I do. I am a structural engineer, like I said, and I just wanted to teach you guys about civil engineering, and maybe, hopefully, you guys will, after this lesson, learn that civil engineering is right for you. So we're going to launch into the talk today, the presentation. So topics for today are going to be, first, I'll give you a little bit of background about me, where I started and sort of things that led me down my path and how I got here today. Then we'll talk a little bit about what STEM is. I think that one's pretty, at this point, obviously, if you're at this conference, you're well aware of what that is. So we'll breeze past that, but then we'll start to get into more about what an engineer is, a little bit of some particulars about different types of engineering, and then we'll talk a little bit about the education path that's required for engineering. I'll tell you about my path. Every path is not necessarily exactly the same, so we'll talk about different options for career paths. A question I get a lot is how we spend our day, so I'll talk a little bit about what I do day to day as an engineer and what you might expect in any given field that you decide to pursue. So, like I said, I'll launch into talking about myself. My name is Nicole Melendez. You see those two letters behind my name. The PE refer to professional engineer. In engineering, you have an option to become licensed. I'll talk a little bit more about that as we get into some of the requirements of engineering, but I have gotten my professional engineer license, and so I get to slap those two letters to the back of my name. A little bit about myself. I was born in New York City. As a kid, we moved from New York City to York, Pennsylvania. So in New York, I grew up in a low-income family. My high school was similarly low-income. Most students in my high school barely graduated, let alone went on to college. So within my family, I was the first to graduate from a four-year college, something that Mom and the rest of the family were quite proud of. So Mom did a lot to make that happen. So then that comes up a little bit later in terms of why that's important in my particular path. But as a kid, I loved to tinker with things. If there was a toy that I had and it was broken, I was begging Mom for a screwdriver so I could take it apart and figure out what happened to it or how I could fix it. So that was sort of one of the first signs for me personally that engineering was the way to go, or something that I was going to be interested in. So another thing I loved to do as a kid was go back to New York. Like I said, born in New York City, so we had family there that we would regularly visit. And I just have vivid memories of driving across the bridges or through the tunnels into the city, and just kind of having my face planted up against the car window, looking at these huge bridges and these huge buildings, and as a kid just very curious about how they were constructed and how they were built, and different family members who would sort of help me understand kind of that, and was always enamored with that sort of thing. And then after high school, I got to go to college, and so I went to school at Rutgers University. I have a degree in civil engineering from Rutgers University. I knew that I wanted to be back in the New York metro area, but I wasn't sure if I wanted to be in the city or somewhere just outside of it. And so Rutgers presented a really great opportunity, and it was a great mix of both of those things. So I had enough space outside of the city where it wasn't too congested or crazy, but at the same time I could get on a train and head into New York anytime I wanted to see all the things that I was so passionate about as a kid. So then, like I said, currently I'm a structural engineer and project manager in New York City. In my office, my company, we focus specifically on long span bridges. And so that's where the bulk of my expertise has been. I've been an engineer for almost 20 years now. So that concentration has been in long span bridges. And so for some of you that might not know what a long span bridge is, it's just a couple of examples, but these are some of the more famous ones, coincidentally in New York, but obviously there are long span bridges all over the world that I've gotten to work on. So up on the top left, we've got the Verrazano Narrows Bridge, which connects, this is Brooklyn and this is Staten Island. And back here in the background, you can see the skyline of New York City. So that actually is the largest suspension bridge in the country. I think it's about third in the world or somewhere around there. And then this one down here, a bit older, but arguably the most famous bridge in the world. This is the Brooklyn Bridge, also in New York. And had the chance to work on that for several years, and still to some degree I'm working on that bridge now with some rehab work. So like I said, Verrazano and Brooklyn Bridge. So now we'll launch into a little bit more about STEM and engineering specifically, and maybe trying to help you get a better understanding of what type of engineer you might be interested in being. So as I said before, if you're at this conference, odds are you know all of these things, but the STEM is an acronym: science, technology, engineering, and math. And today we're going to focus on engineering. So what is an engineer? This is a question that I think even a lot of engineers have problems answering directly, or coming up with a concise answer anyway. So what I like to describe it as is engineering in general is a very broad topic. Even within engineering, specific disciplines are very, very broad and all-encompassing of a lot of topics. So in general, an engineer is a person who builds or maintains engines, machines, or public works. And I think engines are sort of straightforward. That's something easy to understand. Machines this is sort of machines in a general, very, very broad sense. So a computer could be a machine could be a car part, some sort of machine. And then public works, I think, is the one that is the most, again, all-encompassing or most general. You can think of public works as a water system or a water treatment facility. You could think of public works as bridges or highways. You could think of public works as the electrical lines that are running through your city. Basically, all of the components needed to make a society function. That is sort of the all-encompassing word of public work, or the all-encompassing description of public works. And so an engineer then is a person with a broad knowledge of a lot of these things, or these materials that are required for these things. And then it's our job as an engineer to take that knowledge and then find the most effective or efficient ways to apply that knowledge to solve real world problems. So the simplest answer I usually give people is, it's my job to solve puzzles for a living. So if there's some complex puzzle, I get very excited about that sort of thing and trying to figure out how to solve it. So now we'll launch a little bit into different types of engineers. If you're thinking about the engineering track, or if you're already in it, but maybe in some of the beginning stages, at some point you'll have to, as you start to enter the engineering curriculum or education system, the first year or two may be kind of general engineering, and you won't necessarily need to declare just yet in terms of type of engineering. But as you get, I think at Rutgers we had to decide our second semester of sophomore year. We had to choose a major, and then that's when your classes start to get a little more unique to your particular degree. So a couple of the different types of engineering, and again, there are many more than this. This is not meant to be all-encompassing, but one of them, biomedical engineering. So if you're interested in medical devices, if you're interested in means of applying engineering in the medical sense, that's going to be more of a biomedical engineering situation. Electrical engineering can be a lot of computers, a lot of electronics. Sometimes electrical and computer engineering, which you see further down the list, can sometimes be lumped together. Another one is mechanical engineering, which is a lot of manufacturing systems. And for instance, if you're working for Amazon, I've got several friends that are industrial engineers working for Amazon building their facilities. So it's all about trying to come up with the most efficient ways to get a product from one spot in the facility to another spot in the facility and moving that as efficiently as possible. Another type is mechanical engineering with a lot of robots. That's a very common thing you'll see on college campuses, are students in the mechanical engineering department building robots or cars. And then similarly, I have mechanical engineering friends that are working on planes at Boeing, plumbing, heating, HVAC systems, and all sorts of machines. Computer engineering, I mentioned up top, similar to electrical. And then the one I'm going to focus on today is civil engineering. So civil engineering, like I talked about before with public works, is predominantly all public works. So civil engineers are going to be responsible for roads and bridges, dams, and different types of buildings if they're sort of a community-based versus a private building, and a slew of other things that there's a whole list of things. So civil engineers, I talked about public works and things that are encompassed in public works. And for me, part of when I knew I wanted to be an engineer was when I learned this word that's on the screen right now. I think maybe I was a bit older than I should have been, but I was probably about 18 or 19 when I learned the definition of the word infrastructure. And it was the first time that I felt like there was a word that described what I was interested in. And so if you don't already know what that word is, it's basically an all-encompassing word to mean the basic facilities and structures that are needed for a society to function. So for me, if I was walking down the street, I was really interested in the roadways or the bridges or things like that. So like I mentioned a bit before, that's water systems, it's transportation systems, so the trains and the highways, and then a bit further, civil engineering. When you're in your education system, you're gonna learn all sorts of you're going to take all sorts of courses as civil engineer, including construction management. You'll take some environmental engineering courses, you'll take some geotech engineering courses, and you'll take some structural courses, structural design courses. And those are the courses that for me were the most intriguing. So designing steel structures, designing steel bridges, designing concrete structures, those types of courses were the ones that were most intriguing for me. And so typically when you are focused on the structural track, you'll want to, the further you get into it, you'll end up sort of wanting to decide between more of a bridges track or more of a buildings track. And in my case, I was drawn to the bridges for sure. So again, right now I want to just talk a little bit about the education path. Like I mentioned before, high school and college. So in high school, a lot of the courses I was taking unintentionally, just the courses I was just naturally interested in, ended up being courses that were helpful for the engineering degree. And in some cases, if you're able to take an AP course, you may be able to place out of courses in college and things like that. So in terms of math, it was trig, calculus, if those courses are offered in your high school. Other courses in science were physics and chemistry. I was lucky enough that my high school physics teacher was an incredible teacher. I credit her a lot with helping me realize that engineering was something I was interested in. And I also was lucky in that my high school offered two different years of physics. So I had a physics 1 junior year and then a physics 2 senior year. So that helped in terms of the AP exam and just coming into college, I think, on a much better footing than a lot of my peers in terms of physics. So that was very helpful, and I was very grateful for that. And then additionally, programming. And the last bullet I have on here, I think, is one that people don't always associate with engineering, but writing is absolutely a critical part of engineering. It's not to say that you're going to be writing term papers or anything to that degree every day, but we are very often having to communicate things to contractors, having to write things for clients, and a good, solid foundation in writing is critical. We've had many people who are incredible math engineers, and then the people that typically will stand out are the ones that are capable of writing and solving the equations. So writing is absolutely a great tool to have if you want to be a good engineer. And then past that, like I mentioned, college. I have a degree, an undergrad degree. A lot of people, specifically in civil engineering, will go for a graduate school degree. I opted not to, and it took several years for me to arrive at that decision, but I opted not to in the end because I had a really good job and things were moving in a positive direction for me. But a lot of people I know did get graduate degrees, and it helped them sort of have a leg up in getting those jobs. And then additionally, the last step, and this one is pretty prevalent in civil engineering, a little less so in some of the other types of engineering, but the licensing in the engineering world, because we do a lot of public works, we need to be licensed if we're going to be signing off on drawings, versus some people that maybe are designing, heating and cooling system, and maybe that's not as critical in terms of people's safety and things like that. Whereas if I'm designing a bridge or my coworker is designing some mechanical portion of a structure, where its failure is involving people's safety, then you want that person to be licensed. So the accreditation process or the licensing process for that is you take one 8-hour exam just out of college, and so that's that FE or EIT, which is the Fundamentals of Engineering or Engineering in Training degree, or sorry, certification. And then after 4 years experience, you can take the PE exam. And so that's the professional engineering exam that I mentioned before. And that is an accreditation or license that I do have. And so then that allows you to officially sign drawings and officially oversee certain types of work and things like that. And then a step past that is for some folks then opt to also get their SE, which is the structural engineering certification or license. And that's another exam. That one is a 2-day exam, and very, very hard exam. But so that one I haven't done, and I don't think at this point in my career I need to. But there are a lot of typically a lot of areas with high seismic zones. So maybe some folks in California that may be required on some jobs there and stuff like that. So. And so now a little bit about how we spend our day. How you spend your day is going to vary a lot by what type of company you're at in terms of the opportunities that you have. If you're at a larger company, a lot of times what will happen is each person sort of has their particular niche skill or talent that they work on. Versus if you're at a smaller company, you're going to get more of a hands-on role in all of the different tasks on any given job. So that's just a matter of preference or just a matter of where you find your first job. You can give it a feel, see how you feel about it. If it's something you like, you can stick with it. If it's something where you think you'd like to try the opposite end, it's just a matter of what fits best for you, basically. And then in terms of day-to-day, our days can be split between office work and field work. And so in the office, we're doing either design calculations or we're running computer models or we're preparing details for a client where a lot of times there are only a certain number of brand new bridges being designed on any given day. So a very large part of our work is actually repairing and maintaining existing bridges. So that's where those repair details will come into play. So we are evaluating existing structures, if there's been some corrosion or there's been some sort of impact damage because a car hit a portion of the bridge or things like that. That's where that type of work will come in. So we do a lot of repair work and just maintenance and maintaining, monitoring portions of the structure. And then additionally is field work. The level and amount of field work you will be exposed to is completely up to you. I personally have chosen to do a lot of bridge inspection and a lot of construction management. So that will have me out in the field very high up on bridges. It's something that I enjoy very much and very comfortable with, but it's by no means is it ever required of anybody. So if it's not something that you're comfortable with, you should not write off bridge engineering just because it's something you don't want to do. But I've got a few photos here of some of the field work that I personally have done. So this is a bridge, and I mentioned, our office does long span bridge work. So this is a bridge in Michigan. This connects the Upper Peninsula and the Lower Peninsula for anybody that knows the area. It's Mackinac Bridge. And so this is a time where we were in the field doing some inspection work. So my company designed this bridge in the 1950s, and we have maintained the inspection and maintenance contract since the bridge was open to traffic. So this is just an example of some of the better days at work where we get to have get some fresh air and be up there and get some incredible views. Additionally, this is some more field work. So this I showed the Brooklyn Bridge earlier with the long span bridges examples. So this is the Brooklyn Bridge. In this case, we were walking the cables to inspect the main cables and check out some things at the towers here. So you can see back here, obviously a very famous skyline, but that's the World Trade Center. And for anybody that's been at the Brooklyn Bridge, just sort of behind me here in the middle is the walkway or the promenade that a lot of times people will come visit the Brooklyn Bridge and walk along. So these are just a couple of the holy grail bridges for some of us in the long span bridge world. So I'll just kind of, again, talk a little bit about why engineering might be good for you, or what sorts of things were interesting to me when I was younger, and then maybe you feel like similar things are interesting to you, and so that might pique your interest to look more into certain types of engineering. But like I mentioned, I was very into math and science in high school. Again, talking about my incredible physics teacher, I just remember one of the first weeks of class in physics, and she made some very simple demonstration that was the first time that I sort of saw math equations or something applied to the real world. I think it just kind of sent a light bulb off in my head, and it was great in terms of realizing that there was a way to apply things to the world around us. And so like I mentioned before, I loved puzzles, still do. Trying to solve problems, and complex problems is the more complex the problem, the more rewarding it is to figure out the answer. And then, like I mentioned, just the ability to apply the things that we're learning in math and science and all these courses, and then seeing how they apply in the real world. So those are all things that I think if those things interest you, then engineering is certainly the way to go. And then this is always a picture. This is a picture I usually put up and just tell folks like if this photo is interesting to you, then civil engineering in particular is probably very interesting to you. I mentioned public works, and so this is actually an area where there was this photo is probably about 6 or 7 years old. If you were to be in this area now, there's a brand new bridge here in parallel to this old one. This old one has since been demolished. And I spent 4 or 5 years on the design and construction of this bridge. Actually, you can see down here these trailers. This was the start, the very beginning of construction as the contractor was starting to mobilize and get on site. But you've got a lot of infrastructure here. You've got the ports of Newark here, which is where most of the goods come into the United States from up the Panama Canal, and everything's sort of dropped off here and put onto the trains and sent distributed all over the country. You've got bridges here. Obviously, you've got a major highway, which is running here in this direction, and this is the on-ramps and off-ramps for that highway. And what's just out of two important things are just out of focus here, but the Newark Airport is just to the left here. It's one of the biggest airports in the country. And then additionally, the New York City skyline is just past where this photo is cut. But in general, this is the type of thing that this is civil engineering sort of to a T. So everything in this photo is basically everything that I do on any given day. So if this type of thing is interesting to you, then civil engineering is probably something for you to also look into. So with that, I'll just a few final thoughts. Some of the things I wasn't able to touch on specifically in the talk, but I think representation is a huge cannot be overstated how critical it is to have something that you can see in front of you or be able to emulate in your own career. Obviously, if you're at this conference right now, then you're already doing a great job in terms of making sure that you're seeing these things and making sure that people are seeing you. I think everyone here is entering the market at an incredible time. You're entering the STEM field at an incredible time. You probably hear a lot in the news or you just hear a lot of things about infrastructure spending. That basically what that means is everyone here is going to have a lot of job opportunities. Whether you're still in high school or whether you're still in early college, the great news about hearing infrastructure spending is that STEM will always have job opportunities, always have career opportunities. Earlier this week, I did a career fair at a very prominent engineering school, and a lot of the students were asking what sorts of qualifications are we looking for in interns and what sorts of qualifications are we looking for in first level or beginning level engineers. I think the number one thing is just drive or passion and curiosity. So if you're curious about any of the things I mentioned here today, you're already ahead of the game. And if you're working with people and you're asking questions and you're inquisitive and you want to learn things, I think that's a great thing. I think a lot of engineers, everyone takes all the same courses. So when we look at a resume, especially for a junior person or an intern, the resumes in terms of coursework and things like that will all be very similar. But if I'm having a conversation with you and I can really tell that you're interested in what we're talking about and you're interested in this path that you've taken so many years to study, then that's going to be extra points on your resume in terms of that as we're making decisions. And then to that point, I think my next bullet here is don't be afraid to. So don't be afraid to be wrong. Like it's part of learning. If you have a question, ask it. We as senior engineers would much rather you ask a question and get the right answer and can move on instead of you maybe sitting there and spinning your wheels for a couple hours and not sure what you're doing. And it shows some, like I mentioned before, it shows some curiosity and some motivation and things like that to want to make sure you get the job done. And then additionally, don't be afraid to ask for help. Don't be afraid to ask to help. A lot of times, some of our best interns have been the ones who have come up to us on any given day and said, hey, do you have anything I can help with? As somebody as I personally will have a lot of things on my plate, to have somebody come to me and say, hey, can I help you with what you're working on is it earns you a lot of points. It's incredible. It's incredibly helpful both for the engineer that you're helping, and then it's incredibly helpful for you because you're getting exposure that you may not have otherwise gotten. So don't be afraid to, like I said, don't be afraid to ask for help, and don't be afraid to ask to help someone. And to that point, I think another thing that is kind of often overlooked is the mentor-mentee relationship. And that can be a formal mentor where you say, hey, will you be my mentor? Or that can just be somebody that you maybe have some questions or you can bounce some questions off of. Um, that relationship will help you and just get you farther ahead in all sorts of ways. Um, and yeah, so like I mentioned too, there's just a multitude of different paths to get to the same goal. So I talked today about my particular path. Your particular path may be a little bit different, but if ultimately your goal is to work as an engineer, you're going to have your own individual path, but it will get you to that goal regardless. So yeah, let's see. So yeah, with that, I wish you all good luck. I talked about mentoring. This photo here is actually a picture of me up front, and then this group of students back here, with the exception of the second one back, who is my high school physics teacher. But this was a group of students from my high school that are currently her students. So they actually had an opportunity to come visit a construction site that I was working on, and just in terms of mentoring and menteeing, I think they got to learn a lot about a bridge being built, and hopefully they all came away as little miniature bridge experts and got to go back and spread that knowledge. So again, I wish you all good luck. I hope that you enjoy the rest of the conference. I'm sure you'll have a great time and learn a lot. I've got my LinkedIn contact info down here at the bottom of the screen, and I have my contact info with the organizers of the event. So please feel free to reach out if you have any questions. If you're curious about whether the path that you're on in terms of engineering is the right one, or if you need some help making some decisions, feel free to reach out. I'm happy to offer up some of that mentoring role that I was just talking about. So please do. And again, the best of luck. Thanks, everybody.